Longest lightning flash ever recorded, 515 miles. Did you know that lightning can stretch across more than 500 miles in a single flash? Scientists have just declared a groundbreaking discovery. A lightning strike measured at 515 miles, 829 kilometers, has now become the longest ever recorded. This extraordinary event, captured on October 22nd, 2017, occurred over the Great Plains of the United States, spanning from East Texas to near Kansas City, Missouri, a distance comparable to flying from Paris to Venice. But here's where it gets controversial. The previous record of 768 kilometers was also set in the same region, a hotspot for severe thunderstorms, back in April 2020. How did scientists track such vast distances? Since 2016, advances in space-based technology have revolutionized how we measure lightning. Satellites now provide a broader view, allowing researchers to capture these extreme flashes that were previously invisible to ground-based sensors. Michael J. Peterson, a leading expert from the Georgia Institute of Technology, explains, studying lightning's extremes is challenging because it pushes the limits of our observational tools. The use of geostationary satellites has been a game changer, offering continuous data from orbit. Before satellites, data relied on ground sensors, which had clear limitations in capturing long-distance strikes. Now, the latest tech even reveals the longest duration for a single flash, 17.1 seconds, recorded in Uruguay and northern Argentina in June 2020. And this is the part most people miss. Lightning doesn't always stay close to its storm. As Prof. Randall Cerveny of the WMO notes, lightning can travel far from its parent storm, which means people should avoid outdoor activities during thunderstorms. The WMO urges those caught in lightning storms to seek shelter in sturdy buildings or fully enclosed vehicles with metal tops. So next time you hear thunder, remember, nature's lightning might be far more powerful and unpredictable than you think. What do you believe about lightning's reach? Share your thoughts in the comments below. Record-breaking lightning strike. The 515-mile Megaflash explained. A jaw-dropping discovery has electrified the scientific community, revealing a lightning strike that stretched an unprecedented 515 miles across the southern United States in 2017. This Megaflash, as it's been dubbed, outshines the previous record holder by a significant margin, proving that nature's power knows no bounds. But here's where it gets controversial. Could this phenomenon pose a greater threat to public safety and aviation than previously thought? The World Meteorological Organization, WMO, announced that this extraordinary lightning bolt, equivalent to the distance from Boston to the Outer Banks of North Carolina, or from Brownsville, Texas to the Oklahoma border, emerged from a vast thunderstorm complex known as a mesoscale convective system. This storm system spanned from near Dallas to just east of Kansas City, Missouri, illuminating parts of Texas, eastern Oklahoma, northwest Arkansas, southeast Kansas, and southwest Missouri, simultaneously. An area 5 times larger than Massachusetts was lit up by this single flash, surpassing the previous record of a 477.2-mile-long bolt that discharged across the southern plains on April 29, 2020. Lightning specialists are astounded by the exceptional duration and size of this megaflash, which can occur in sprawling storm clusters with horizontally expansive areas of electric charge. Most thunderstorms are less than 10 miles tall, so to witness a megaflash, one would need a long or wide thunderstorm complex. The WMO's Committee on Weather and Climate Extremes utilized data from the GOES 16, 17, 18, and 19 satellites, positioned 22,236 miles above Earth's surface, to map the origin of the flash. These satellites can sense lightning discharges from above, even if they don't strike the ground. The data was then combined with ground-based lightning strike data from the Earth network's total lightning network, revealing that the same ultra-expansive flash produced 64 bolts that struck the ground. The evaluation committee member, Michael J. Peterson, a researcher at Georgia Tech, noted that adding observations from satellites was the final piece of the puzzle in understanding the extremes of what lightning is capable of. Megaflashes are also known for their duration, with one bolt spending a total of 17.1 seconds discharging over Uruguay and northern Argentina on June 18, 2020. Randy Cerveni, a researcher and professor at Arizona State, emphasized that the duration of this flash was over 7 seconds. Megaflash research is crucial for scientists to comprehend the geographical extent of lightning hazards, particularly since flashes can travel far distances from the initial region in the cloud containing charge. Scientists have coined the term bolt from the gray to describe this type of lightning event, which appears to come from clear skies. However, as with all lightning, it actually originates from a thunderstorm, but from a very great distance. These megaflashes can travel immense distances from their origin point. The WMO's announcement also highlighted 2 other lightning records, both for fatality counts from single strikes. In 1975, 21 people in Zimbabwe were killed by a bolt as they huddled inside a hut for safety. And in 1994, 469 people were killed in Dronka, Egypt, when lightning struck a set of oil tanks, sparking a fire and causing burning oil to flood the town. This discovery raises important questions about the potential impact of megaflashes on public safety and the aviation sector. Could these electrified clouds produce flashes that travel extremely large distances and spark wildfires? And this is the part most people miss. How can we better prepare for and mitigate the risks associated with these phenomena? Share your thoughts in the comments below. Record-breaking 515-mile lightning megaflash, nature's epic electric display. Imagine a bolt of lightning so colossal it could stretch from one state to another, like a glowing electric whip lashing across the sky for over 500 miles. That's exactly what happened in October 2017, when a record-breaking megaflash rewrote the rulebook on nature's most dazzling spectacle. But here's where it gets controversial. Could this monstrous lightning strike be just the beginning of a new era in storm science? Or a one-off freak of nature? Let's dive in. In 2017, a single lightning flash, yes, just one, crisscrossed the Great Plains, starting in eastern Texas and ending near Kansas City, Missouri. At a staggering 515 miles long, it shattered the previous record of 477 miles set in 2020. This wasn't just a random bolt. Scientists now call it a megaflash, a term reserved for lightning that stretches more than 62 miles. To put that in perspective, the average lightning strike is less than 10 miles long. And this is the part most people miss. Only 1% of thunderstorms even produce megaflashes, according to satellite data analyzed by Michael Peterson of the Georgia Tech Research Institute. So how do you measure a lightning bolt that could rack around a state? Until recently, researchers relied on ground-based antennas to track lightning by detecting radio signals. But the game changed in 2017 with the launch of advanced satellite tech. Randy Cerveni, a professor at Arizona State University and co-author of the study, explains, our weather satellites now capture lightning with millisecond precision, mapping its path in real time. The NOAA's GO-16 satellite, equipped with a lightning mapper, detects around 1 million strikes daily. Data that's revolutionizing how we understand these electrifying giants. Megaflashes aren't just long. They're born from marathon thunderstorms that rumble for 14 hours or more. Picture a storm system as vast as New Jersey, churning with energy until it spits out a lightning bolt that could circle a continent. Yet, here's the twist. While megaflashes are rare, ordinary lightning is far more dangerous. Cerveni warns that most lightning-related deaths and injuries occur before or after the storm's peak, not during it. The storm doesn't have to be overhead to strike you, he says. That's why the rule is, wait at least 30 minutes after thunder fades before stepping outside. And this is where the debate kicks in. Could future megaflashes be even longer than 515 miles? Cerveni hints at the possibility, noting that as satellite data accumulates, we might uncover even more extreme examples. Peterson, the study's lead author, calls the satellite revolution a major advance, with geostationary orbit providing continuous coverage of global lightning hotspots. So, what's next? Will climate change fuel more megaflashes? Are we underestimating their danger because they're so rare? Share your thoughts, because when it comes to lightning, the sky's the limit, and the questions are just getting started.